Hey everyone, I'm Ganesh. Today I'll be walking you through everything I've learned so far in my CS5610 Web Development course. First, I'll be explaining the core client-side technologies, HTML, CSS, and JavaScript, the stuff that runs in your browser and creates what you actually see on screen. Then, I'll show you how all these pieces fit together into modern web architectures, both simple two-tier setups and then full-stack three-tier applications. And after that, we'll build a real web page together from scratch, and then I'll dive deep into how Node.js and Express power the backend. So let's get started with the fundamentals, the technologies that make the web work. Alright, so when you load a website, any website, whether it's Google or Facebook or your favorite online store, there are three core technologies working together in your browser. Let me show you what each one does and why we need all three. First up is HTML, the hypertext markup language. HTML is a skeleton, the foundation of every single web page you've ever seen. Think about it like building a house. Before you paint the walls or arrange the furniture, you need the structure, the floors, the walls, the rooms, etc. So that's what HTML does for websites. It says, here's a header at the top, here's a navigation menu, and here's a main content area, and here's a footer at the bottom. Now what makes HTML powerful is that how we use semantic tags. And semantic just means the tag name describes what it's for. So instead of calling everything in a general div, we use specific tags like header, nav, main, section, footer, etc. So this makes your code way more readable. Plus, it helps with accessibility. Screen readers can understand your page structure much better when you use semantic HTML. And here's something really important. When your browser loads HTML, it doesn't just display it and call it a day. It actually builds something called the DOM, the Document Object Model. The DOM is basically a tree structure in memory that represents your entire web page. And this matters because JavaScript can grab onto any part of that DOM tree and change it dynamically. So we'll see how exactly that works in a minute. You'll see all these HTML tags in action when we actually build something together later on. Okay, so if HTML is a skeleton, then CSS is the skin and clothing that makes everything look good. With CSS, we select elements, either by their tag name, by a class, or by an ID, and then we apply styles to them. So want that particular heading to be in blue, we apply CSS. Want some spacing around your content, CSS. Want a fancy animation, also CSS. Now, one of the most important concepts in CSS is the box model. Every single element on your page is actually a box, even if it doesn't look like it. And each box has 4 layers: the content in the center, the padding around the content, then a border around the padding, and finally the margin, which is a space outside the border. Understanding this is important because it controls all your spacing and layout. Here's where Bootstrap comes in. Bootstrap is a CSS framework, basically a big library of pre-built styles and components. Instead of writing hundreds of CSS lines codes from scratch, you can just add Bootstrap classes and get professional looking buttons, cards, navigation bars, and all the good stuff. And it's responsive by default, which means it automatically works on phones, tablets, and desktops without you having to write media queries for everything. When we build our page in a few minutes, we'll use Bootstrap to speed things up. But we'll also add some custom CSS on top to make it unique. Alright, now we get to JavaScript. And this is where things get really interesting because JavaScript is what makes your pages interactive and alive. So think about it this way. HTML gives you the structure, CSS makes it look pretty, but JavaScript is what actually makes stuff happen. So when you click a button and something changes on the page without reloading, that's JavaScript. When you type into a search bar and get instant suggestions, JavaScript. When you submit a form and it validates your input before sending, also JavaScript. Now, we're using modern JavaScript, especially ES6+, which introduced some game-changing features. Let me walk you through some important ones. First, we have got let and cons for declaring variables, which replaced the old var keyword and gave us better scoping. Arrow functions gave us this really clean, concise syntax for writing functions. Template literals, which are the backticks, let you embed variables directly into strings. And then you've got destructuring and the spread operator, which make working with objects and arrays way more elegant. And one of the biggest improvements is the async await. In web development, you're constantly dealing with things that take time, like fetching data from a server. That's called asynchronous code. In the old ways, we used callbacks, which led to what we call callback hell, the deeply nested mess of code. Then we got promises, which were better, but still kind of clunky. Now with async await, you can write asynchronous code that looks and reads like regular synchronous code. So look at this example here. We mark the function as async. Then we can use the await keyword to wait for things like network request to finish. We wrap all of these in a try clutch for error handling. This is so much more readable and maintainable. And finally, modules let us split our code into across multiple files. You export functions or components from one file and then import them wherever you need them. This keeps large objects organized and makes code reusable across your application. And we'll be using all of these when we build a page together later on. Okay, so I mentioned the DOM a minute ago, the document object model. And I want to explain why this is so important, because it's really the bridge between HTML and JavaScript. So here's what happens. When your browser loads an HTML document, it parses through all those tags and creates a tree structure in memory. Each element becomes a node in this tree. If you look at this diagram, you can see how it works. The body element contains a anchor or a header, and so on. It's just a tree, just like a family tree showing parent-child relationships. And the powerful part is that JavaScript can reach into this tree and manipulate any part of it. We use methods like query selectors to find elements. You can search by ID, by class, by tag, by name, whatever you need. So once you got an element, you can do anything with it. Change its content, modify its attributes, update its style, etc. The page changes instantly without reloading. You can even create brand new elements from scratch using create element and then add them onto the page with append child. That's how you build dynamic content, stuff that appears and disappears based on user actions. And then there are event listeners. This is how you respond to user interactions. So when someone clicks a button, types in an input field, scrolls the page, you can listen for all those events and run functions in response. Your function fires, the DOM is updated, and boom, the user sees a change instantly. This is the magic of modern web dev. No page reloads, no flickering, just smooth instant updates. When we build something together, every user interaction will manipulate the DOM in real time. Alright, so now you understand the building blocks, HTML, CSS, and JS. But here's the thing, how you actually structure a web application depends on what you're trying to build. Are you making a simple portfolio, or are you building a full social media platform with user accounts and databases? So that's where web dev architecture comes in. There are two main patterns that we use, the 2-tier and 3-tier architecture. So let's start with 2-tier. In the 2-tier architecture, we have got two layers, the client and the server. The client is the browser on your computer or phone. It's running HTML, CSS, and JavaScript, handling everything the user sees and does. The server is just serving up files, the HTML documents, the CSS style sheets, the JavaScript files, images, whatever you need. Now this can work in two different ways, and it's important to know the difference. First, you've got static file serving. This is a simpler setup. You have complete HTML files already written. The server just sends them to whoever asks for them. No processing, no computation, just file delivery. This is perfect for things like portfolio websites, documentation sites, landing pages, etc. GitHub pages also works exactly this way. You push your HTML, CSS, and JavaScript files into a repository, and then GitHub serves them to anyone who visits. Super simple and reliable. The second way is client-side rendering, which is what modern frameworks like React and Angular does. So here, the server sends a minimal HTML file, often just a shell, along with a big JavaScript bundle. Then JavaScript takes over and actually builds the page dynamically in the browser. The advantage here is that after the initial load, the app feels instant because JavaScript can update the page without making a new request to the server. Navigation is smooth, interactions are snappy. But here's a key thing about both of these. They're still 2-tier because the server isn't doing any business logic. It's not processing data, it's not enforcing rules, it's not talking to a database, nothing. It's just serving files. And that's the limitation. With 2-tier architecture, you can't store user data permanently. You can't process payments. You can't handle user authentication and sessions. Everything happens in the browser, which means everything is temporary. Close the tab and it's gone. If you need any of that functionality, you need to add a third tier, which is the database. And that brings us to the 3-tier architecture, the full stack setup. This is what powers basically every major web application you use. Now we have 3 distinct layers and each one has a specific job. The first tier is the client, is still the client, the presentation layer. Once again, this is your browser running HTML, CSS, and JS, handling what users see and how they interact with your application, same as before. But now we had a second tier, the application server. This is the business logic layer. It's running Node.js with Express, and this is where the real work happens. When a request comes in from the client, the application server processes it. It validates the data, enforces business rules, checks if the user is authenticated, coordinates with the database, all of that. This is the brain of your application. And the third tier is the database, the data layer. Now, this is MongoDB in our case, or it could be MySQL, etc. Anything. In our case, it's a MongoDB. This is where all your data lives permanently, the user accounts, posts, transactions, everything. The application server queries the database when it needs data and writes to it when data needs to be saved. Here's why this separation is so powerful. You can update the user interface without actually touching the server code. You can change your business logic without touching the database. You can scale each layer independently. If you need to handle more users, you can add more application servers. If you need more storage, you can scale up the database. They are decoupled. This is the architecture behind Facebook, Twitter, Netflix, any app where you have user accounts, with data persistence, where there's complex business logic happening behind the scenes. Now let me break down each of these components in more detail, starting with Node.js and Express. So let's talk about Node.js first. Node.js is what brought JavaScript to the server side, and that's a huge deal. Traditionally, JavaScript only ran in browsers. If you wanted to write server code, you had to write a different language, Python, Ruby, Java, whatever. But Node.js took Chrome's V8 JavaScript engine, the same engine that runs JS on your browser, and made it work on servers. So why does it matter? Because now you can write both your front end and back end in the same language. You don't have to context switch between languages. You can share code between client and server. And for developers, this is amazing. Node.js is also event-driven and non-blocking, which means it can handle thousands of concurrent connections really efficiently. When a request comes in that needs to wait for something like a database query, Node doesn't just sit there doing nothing. It moves on to handle other requests and comes back when the data is ready. This makes it super efficient for building APIs and real-time applications. Plus, we get NPM, the Node Package Manager, which gives you access to millions of packages. So if you want to work with dates, there's a package. Want to handle authentication, we have a package, and it's an enormous ecosystem. Now, let's go on to Express. Express is a web framework built on top of Node.js, and it makes building servers so much easier. Without Express, Node's built-in HTTP APIs are really verbose and low-level. Express gives you clean and simple abstractions. Say, look at this code, for example. We create an Express app and some middleware to parse JSON, then define routes. A route is basically when someone makes a GET request to this URL, run this function. GET request fetch data, post request create new data, put updates existing data, and delete removes data. It's all very intuitive. And middleware, we are going to dive deep into middleware later, but basically it's functions that run before your routes, handling things like parsing request bodies, logging, authentication, all this cross-cutting stuff. Express is what we'll be using to build our backend, and you'll see how it connects to MongoDB to create a complete API. Now, let's talk about HTTP protocol, the Hypertext Transfer Protocol, because it is literally the protocol that powers the entire web. It's how clients and servers talk to each other. HTTP is based on requests and responses. The client sends a request, hey, I want this data. Now, and the server sends back a response, hey, here you go. Now, HTTP has different methods, and each one means something specific. These map perfectly to CRUD operations, which stands for create, read, update, and delete, the 4 basic operations you can do with data. Get is for reading data. When you load a web page, that's a GET request. Post is for creating new data, like when you submit a form to create a new account. Put is for updating existing data, like editing a profile. And delete is for deleting things. Let me show you how this actually works. Say the client wants to get a list of users. or any API data, for example. It sends a GET request to API. The server receives that request, processes it, and then maybe it queries the database and then sends back a response. The response has a status code and the actual data. Status codes tell you what happened. Like 200 means okay, everything worked. 201 means something was successfully created. 400 means bad request, and so on. Understanding this request response cycle is fundamental because every time you interact with a web application, like clicking a link, submitting a form, loading new content, there's this HTTP dance happening behind the scenes. All right, let's move on to the last piece of the puzzle, MongoDB, the database. This is our database where we store all our data permanently. Now, MongoDB is what is called a NoSQL database, which means it works differently from traditional SQL databases like MySQL or PostgreSQL. In an SQL database, you have tables like rigid schemas. Every row has to have the same columns. If you have a users table with ID, name, and so on, every user must have those exact values. You can't just add a new field for one user without altering the entire table structure. But MongoDB takes a completely different approach. Instead of tables, we have collections. And instead of rows, we have documents. Each document is basically a JSON object. It looks just like JavaScript objects. And here's the key. Documents in the same collection can have completely different structures. Look at this example. One user document might have name, email, and a skills array. Another might have all that plus projects array with nested objects and so on. A third user might have completely different fields. So MongoDB basically doesn't care. It's totally flexible. This flexibility is perfect for modern applications where your data structure evolves as you build. You don't have to run migrations every time you want to add a new field. And since MongoDB stores data like JSON-like documents, it works beautifully with JavaScript. And you're already thinking in objects, so the database naturally fits your mental model. You can nest objects inside objects, store arrays, go multiple levels deep, whatever your application needs. In a SQL database, you'll have to split this across multiple tables and join them. In MongoDB, it's all just one document. Now, MongoDB Atlas is the cloud-hosted version of MongoDB, and this is what I'd recommend for learning and for production. You don't have to install anything on your computer. You don't have to maintain a database server. You don't have to worry about backups. You just have to create a cluster in the cloud and connect to it from your application. So they have a free tier that's perfect for learning and for small projects. And we still do the same crude operations: create, read, update, and delete. So we use insert one to create documents, find to read them, update one to modify them, and then delete one to remove them. Same concepts, just working with flexible documents instead of rigid table rows. Later on, we will be diving deep into how Express actually connects to MongoDB, how you structure endpoints, etc. All right, so bringing this all together, you can now understand the complete picture of modern web development. On the client side, we have HTML for structure, CSS for styling, and then JavaScript for interactivity. That's the presentation layer, everything the user sees and interacts with. On the server side, we have Node.js, Express handling the business logic, processing requests, validating data, enforcing rules, coordinating everything. And at the data layer, we have MongoDB storing everything permanently in flexible JSON-like documents. These three tiers working together, that's what makes or powers modern web applications. So now that we have understood everything, let's build something real. I'll be creating a web page from scratch using HTML, CSS, and Bootstrap and JS. So you will see all of these client-side technologies in action: how the HTML structures the page, how CSS and Bootstrap make it look professional, and how JS makes it interactive, and then how the DOM manipulation happens in real time. All right, so we have covered all the theory. Let's put it into practice and build something real. I'm going to be creating a calculator from scratch using HTML, CSS, Bootstrap, and JavaScript. You'll see how all these technologies work together, how HTML provides a structure, CSS and Bootstrap handles styling, and JavaScript makes it actually function. I'm going to be using VS Code for this, which is a popular code editor. And I've created 3 files here: index.html for the structure, styles.css for the styling, and then script.js for the functionality. And I'll also be using a reload server here so that you can see all the changes live as and when I code. Let me just start the server first so you can see here. Okay, now let's start with the HTML file. So every HTML document starts with doc.html, And this is the basic structure of the HTML document. Now in this head section, we have meta tags. The cars at UDF-8 like handle special characters. The viewport meta tag like is crucial for responsive design, and then it tells like mobile devices to use their actual width instead of pretending to be a desktop. Now I'm going to be linking Bootstrap's CSS from their content delivery network here within the head section. And yes. So this single link gives us access to all of Bootstrap's pre-built styles and components, which is that's the power of CSS frameworks, like in instant professional styling without writing anything from scratch. So if once I save this, you can see the file will be updated here. Once I reload. Now I'm going to also be linking our custom CSS file style, so CSS here. Yeah. Now once that is done, let me just also update the title calculator because we're going to be building a calculator. Now let's move to the body. In the body, I'm going to be using Bootstrap's container class. So this will automatically center our content and add appropriate margins based on screen size. And I'm going to be using h1 heading, which has several Bootstrap utility classes like text center, text white, and so on. Let me just show you. Moving on, I'm going to be using Bootstrap's card component to give you like a card structure, just like how every single calculator looks. Let me just add that first. So this card component, I'm going to be like cards give you this nice contained box like a shadow with shadows and rounded corners built in. And then the MX auto that I'm using here will center the card horizontally, where MX is margin on the x-axis and the auto centers it automatically. Now the inline styling here sets the max width of 400 pixels so it doesn't get too wide on large screens. Now the display is an input field. Form control is Bootstrap's base form styling, and then form control LG makes it large and easy to read. That's why we can see it here. And then the text end aligns the text to the right, just like real calculators do. So I'm going to be setting it to read only so that users like can't type in directly. They'll have to be using buttons to enter numbers, just like in a real calculator. And then this ID is equal to display is really important because JavaScript will use this to access and update the values, like given the starting value is 0. Now for the buttons, I'm going to be using Bootstrap's grid system. Let me just get that code. Yeah. So the regrid and gap 2 creates a grid layout with gaps. Now each row contains columns. Call 3 means we take up 3 out of 12 columns. Now Bootstrap uses a 12 column system. So 3 times 4 gives us 12, giving us 4 buttons per row, as you can see here. Now for the buttons, BTN is Bootstrap's base button class. So the BTN danger makes the clear button red, danger for destructive actions. Now on BTN light makes buttons light gray, like the number 789 here. Now and then the W100 makes each button fill its column width completely. Now the on-click attribute here is key because this connects our HTML to JavaScript. So when clicked, it calls a JavaScript function with the button's value. Now that is how we make it interactive. Now we'll be defining these functions when we get to the JavaScript file. Now let me just add the rest of the rows following the same pattern. Now the second row is gonna include the division operator and then the numbers 4, 5, 6. As you can see, and then the third row is for multiplication and the numbers 1, 2, 3. And then the fourth row is for subtraction, and then the 0, decimal point, and addition. And finally, we'll add the equals button, spanning the entire width with a green color. Yeah. So once we have done that, at the bottom, before closing the body tag, I'm going to be linking our JavaScript file. So it goes at the end so that the HTML loads first, and then JavaScript needs the HTML elements to exist before it can manipulate them. Let me just add that at the end. And we just close divs. Yeah, once the divs are closed, yeah, all the divs are closed now. And that completes our HTML file. Now let's create a CSS file to add custom styling. Now Bootstrap handles most of our layout and component styling, but we'll add some touches to make it unique. Let's go to the CSS file. First, the body background. I'm going to be using a linear gradient instead of a solid color. This will create a smooth color transition from one color to another. So I'm going to be using body. And in the background, I'm going to be using linear gradient. The 135 dig makes it diagonal, going from top left to bottom right. And I'm going to be using 667A. The colors go from a purple blue to a deeper blue. And then 664A2. So this is way more like visually interesting than a flat color. Once, as you can see, the background changes. Now I'm going to be adding min height. So the min height 100 VH ensures it covers the full viewport height. Yeah, you can see how it changes to a linear gradient smooth background. So basically VH stands for viewport height, and 100 VH means 100% of the browser window height. So even on really tall screens, the gradient fills everything. And then finally, I'll be adding the padding. I'll be doing 20px. So padding of 20 pixels gives us some breathing room around the edges on all sides. So once this is done, for the display, I'm going to make the font larger, like a 2 rem is twice the root font size. I'm going to be doing that. So let's go to the display, and then the font size 2 rem, and then change the font weight to bold. You need the semicolon at the end. So font weight bold makes the numbers clear and easy to read, as you can see the difference. And given the light gray background, the bold font like stands out from the white card. And I'm going to be using the background too. Perfect. Yeah. Notice I'm using the ID selector here with the like hashtag symbol. So this targets just the display element specifically by its ID. Now let's go on update the style the buttons. All buttons get consistent sizing, so I'm gonna give a font size of 1.5 rem, say. So 1.5 mm font with a padding of 20 pixels and 20 pixels of padding top and bottom. And then the font weight as bold. Give it a bold look for the fonts. So this is a type selector. It targets all button elements, but Bootstrap's more specific button color classes will override these base styles when needed. That's the cascading style sheets, which is CSS. Now for the card, finally for the enhancing the cards, I'm gonna update the cards. I'm gonna give a border radius of 20 pixels. So this will give it nice rounded corners, like higher numbers mean more rounded. As you can see, the corners of the box became rounded. And then I'm gonna give a box shadow. So box shadow creates depth and makes it look like it's floating. It takes multiple values: horizontal offset, vertical offset, and then the blur radius, and then color with transparency. The subtle shadow makes the card appear to lift off the background. So I'm going to do just that. Yeah, and then maybe make it 30 pixels and then 3. Yeah, you can see how it changed. So that completes our CSS file. Now finally we need the JavaScript. So let's move on to the JavaScript. For the JavaScript, this is where the magic actually happens and how our calculator will actually work, given this is where the interaction happens. So first I need to track the calculator state, like what's currently happening. So let me create 3 variables for that. So let me just create 3 variables, like current input, previous input, and operator. Yeah, something like this. So the current input will store what the user is currently typing, the numbers that you see building up on the display, like when you click. Then the previous input stores the first number when they're actually doing a calculation, like the 5 and 5 plus 3. And then the operator will store which operation the user selected, like plus or minus or multiply or divide. Now this is called state management because we keep track of the application's current condition at any moment. Now let's define an update display function. So this function updates whatever you see on screen. It's how JavaScript communicates changes to the user. And since we want 0 to be displayed by default, I'm going to be adding a 0 here. Or you can also include previous input, but okay, let's just add 0 for now. Get element by ID is how we access the DOM elements, just like how we discussed in the DOM object like a few minutes ago. And then this reaches into that tree and then grabs the display input element by its ID. Now we set its initial value to current we set its value to current output, or 0 if current output is empty. The OR operator means OR. This is simply the OR operator. Now let's create the append number function. When someone clicks a number button, this function runs. The number comes in from a parameter. That's what gets passed from the onClick attribute in our HTML. As you can see, once you click numbers, now you can see it being updated. So if they're trying to add it, I'm just checking if they're trying to add a decimal point here, and if the number is a decimal and then current input already has a decimal, we return early to prevent multiple decimals in one number. You can have like 3.5.7. That would break our calculation. So I can't add more than 1 point here. That's why I'm adding this condition. And then the includes method checks if a string contains a certain characters. And then finally, we call the update display to show the change immediately. That's why we see the numbers being updated here in the input section. Let's go and define the set operator now. So when they click an operator button, plus, minus, multiply or divide, we need to save some information. First, we'll have to check if the current input is empty, because it cannot operate on nothing. If they click plus without entering a number, first just ignore it. And if there's already a complete operation waiting, meaning we have both previous input and an operator, we calculate that first before setting the new operator. This lets you chain operations together like 5 plus 3 plus 2 without hitting equals between each one. Then we save which operator they click, move the current input into previous input for safekeeping, and then clear current input so this they can type the second number. So after clicking 5, then plus, the previous input will become 5 and the operator is plus, and now the current input will become empty, waiting for the next number. Now let's define the core function, which is a calculate. This calculate function is where the actual math happens. Just the heart of the calculator. So first check we have everything we need, the previous number, the current number, and an operator. And if any of them are missing, just return early, because we need all the operators and the operands, because we cannot calculate it without all the pieces. Now parse float converts our strings into actual numbers. Since everything from the buttons comes in as strings, parse float turns this particular string 5 into the number 5 so that we can actually do math on it. Now the switch statement here checks which operator was selected and performs the appropriate operation. Now this is cleaner than a bunch of if-else statements, but we can do that as well. Now the addition, in case of plus, we just do addition, and then for minus, subtraction, star for multiplication, and then slash for division. But in the division, I'm also checking if the current element is 0, because you cannot divide by 0 mathematically as it's undefined. So I'm just including that check here. So after calculating, we convert the result back to string, clear the operator and the previous input since we are done with them, and then update the display to show the result. Now you can see 2 plus 3 is equal to 5, and then 554 into 2 will give you 108. Now that is done. Now finally we have to clear the display, which is the functionality of this red button here. We need to define that as well. Let me just define that. So the clear display, the clear button is actually simple. Just reset everything back to the beginning, set all our state variables back to empty strings, and then update the display, which will show 0 because of that OR operator in the beginning. So this will give us a clean state to start a new calculation. And then finally just call update display by default. So on here, if we just go 5 plus 6, it will give us 11, and you can just clear display, and it will be, if we reload, it will be in clear display by default. So if I just add, we get a result, and if I reload, it will be 0 by default because of the clear update display called, and because of the OR operator here. So we call update display once when the page loads. This initializes the display to 0 right away. Without this, it will be blank until the first interaction. And we can just go around and test the calculator. 7 into 5 gives us 35, which means it works perfectly. And then 8 by 4 gives us 2, which is also fine, working fine. Let me also divide by 0. 0x divided by 0 cannot divide by 0, just like how we did because of the check we added. So that also works fine. So there we have it, a fully functional calculator built from scratch. So here the HTML provided the structure, the display, the buttons all organized semantically with proper tags and Bootstrap classes for layout. Bootstrap gave us professional styling and a grid responsive system. without writing, and we also add the custom CSS file for additional styling, and then the script.js gave us the actual functionality where the math happens. Alright, we have built a calculator on the client side. Let's understand the backend. How Node.js, Express, and MongoDB work together to create a complete full stack application. This is where 2-tier becomes 3-tier. We add the server layer with business logic and the database layer for permanent storage. Let me show you how these technologies connect. Here's a backend stack, 3 layers working together. At the bottom, we have Node.js. Node.js is a JavaScript runtime. It takes Chrome's V8 engine and makes it run on servers instead of just browsers. Node is event-driven and non-blocking, which means it can handle thousands of concurrent connections efficiently. So when a request needs to wait for something like a database query, Node doesn't just sit there. It moves on to handle other requests and then comes back when the data is ready. On top of Node, we have Express. Express is a web framework that makes building servers much easier. Without Express, Node's built-in APIs are really verbose. Express gives you clean, simple routing and middleware. It handles the HTTP protocol, request and response objects, all of that. And then at the data layer, we have MongoDB. This is our database where we store everything permanently. MongoDB is a NoSQL database. It stores data as JSON-like documents instead of rigid table rows. So this works beautifully with JavaScript since we are already working with thinking in objects. Now let's see how a request flows through the entire stack. A user does something in the browser, maybe perform a calculation in our calculator. Now let's say the calculate 5 plus 3 equals 8. The browser sends an HTTP post request to our server to save this calculation in the history. Express receives this request. First, it hits middleware. Maybe express.json passes the request body, which contains the calculation data like the expression 5 plus 3 and then the result 8. Then the request reaches a route handler, which is our code. The code route handler says, okay, I need to save this calculation. It then calls MongoDB to insert the calculation into the database. MongoDB saves the document and returns the result, maybe the new calculation with its generated ID, for example. The route handler takes that result, formats it, and sends it back as an HTTP response, usually JSON. The browser receives this response. Now the user's calculation is saved. So if they close the browser and then come back later to see the calculation history, it will still be there. This is the complete cycle, browser to Express to MongoDB and back. So Express is a coordinator, which is the traffic controller. It receives requests, processes them, and then talks to the database and then sends responses. Now, looking at the Express routes. Express routes map HTTP methods to functions. This is how we build APIs. Get request, fetch data. App.get for the route, say API/calculations, retrieves all calculation history. This is the read operation in CRUD, maybe showing a user all the calculations they performed. Post requests create new data. App.post saves a new calculation. The client sends the calculation data in the request body. The expression like 5 plus 3 and the result 8. This is create in CRUD. Put request, update existing data. Note the ID in the path, that's a URL parameter. So the API/calculation/123, for example, updates calculation 123. Maybe a user wants to add a note to the past calculation. This is update in CRUD. Now delete request, remove data. App.delete with an ID deletes that specific calculation from history. Maybe clearing old calculations, for example. This is delete in CRUD. So these 4 operations, create, read, update, and delete, are the foundation of any data-driven application. Express makes it easy to map these to HTTP methods, and MongoDB makes it easy to perform these operations on our data. To use MongoDB from Express, we first need to connect to it. We import Mongo client from the MongoDB package, and then this comes from npm. We install with npm install MongoDB, and then we create a new client with a connection URL. If you're using MongoDB at less, the cloud version will give you a new URI. It includes a username, password, and the cluster address. And then we call connect to establish the connection, which is asynchronous. It takes time to connect over the network. So we use await. Once connected, we get a reference to our database with client.db. Here I'm calling it calculator DB for our calculator application. Now we can perform operations on collections within that database. This connection typically happens once when our server starts up. Then you reuse it for all requests. You don't reconnect for every request. That would be slow. And MongoDB has simple methods for CRUD operations on collections. Insert one creates a new document. You pass a JavaScript object and MongoDB saves it. For our calculator, we might save an object with the expression and the result. MongoDB automatically adds an ID field with a unique ID. Find reads documents with no arguments. Find returns everything, all calculation history. You can pass query object to filter, like finding all calculations from today or all calculations greater than 100. And then update one modifies an existing document. You pass a filter to find the document, then an object with the changes. The set operator specifies which fields to update, and then maybe updating a note on a past calculation, for example. And then delete one removes the document. Pass a filter to specify which calculation to delete. This is let's say for example we clear the history of the calculations. Now these operations are asynchronous. They return promises. That's why we use async await in our route handlers. We await the database operation, then we can use the result. Here's a complete example, tying it all together. An express route that saves a calculation to MongoDB. We define a post route for /API/calculations. The handler is async because we are doing database operations. Inside a try catch block, we always need a error handling with our database operations. Things can go wrong like network issues, validation issues, etc. So we get the calculation data from rec.body. This might be an object like expression 5 plus 3 and then result 8, timestamp, and so on, etc. So this was passed by express.json middleware. We call insert one on the calculations collection, passing the collection object. We then await the result because this is asynchronous. If successful, we send back a 201 status, meaning that means created with the result. The result includes the inserted documents ID. If anything goes wrong, the catch block catches the error and sends a 500 with error message. This is a pattern for all database operations in Express async handlers. Try catch for errors, await database calls, and then we send appropriate responses. And that's how Node.js, Express, and MongoDB all work together. So Node runs JavaScript on the server, Express handles HTTP request and routing, MongoDB stores data permanently. Together, they create a complete backend that powers modern web apps. So your browser talks to Express, Express talks to MongoDB. Data flows through this stack and you have a full 3-tier architecture, presentation, logic, and data. Hope you now understand the complete full stack from front end to back end to the database. And thank you for watching this video.